we're going to use the same properties we've discussed previously to condense these logarithms. These are just a little more complicated. So let's begin by taking any coefficients we have and swinging them backwards to become exponents. So this first piece becomes 8 to the 2/3. Well, I can go ahead and actually evaluate that. 8 to the 2/3 is 4. If you don't believe me, you can go ahead and check that on a calculator, but trust me, it's 4. So really, this first piece becomes just natural log of 4 minus the natural log of, I'm going to go ahead and evaluate all this in here too. 3 to the 4th is 81. 81 minus 8 is 71. Or I'm sorry, 81 minus 8 is 73. So I've got these two natural logs being subtracted. Well, as we've talked about, we can condense a natural log, or we can condense any logarithm problem that's subtracting into a division problem. So this becomes natural log of 4 divided by 73 when I condense. So I've now made a single logarithm out of this. That's as much as I'm going to condense it. I don't want to go any further and get an irrational answer, so I'll just stick with that for right now, or for my answer. And again, the second example is looking complicated, but it's going to follow the same rules we've learned previously. I'm going to begin by writing log base a just one time. If you write log base whatever more than once on these condensed problems, you've already done the problem wrong. So log base a of, and I'm going to draw my fraction line in here. Remember, any pieces that are positive will end up in the top of the fraction, like we've talked about before. Any pieces that are negative will end up in the denominator of the fraction. So this first piece is log base a of x. That's positive, so that'll be in the top. The next piece is also positive, so that'll end up in the top. Remember, when two addition problems are being condensed, they'll condense into a multiplication problem. So this, if we want to add a times sign in there, would be x times 9. This next piece, again, it's a little more complex, but it's still just that piece right there. It's a positive, so that will also be in the numerator. So I'll multiply that piece as well. I'll keep it in parentheses, so 9x plus 1. And then finally, this last piece, this 5, is being subtracted, so that piece will end up in the bottom of the fraction in the denominator. So if I go ahead and make this look a little bit neater, I'll have log base a of 9x times x squared plus 1 all over 5. Or I suppose if I even want to go ahead and distribute in the numerator, I can do that if I wanted to. And I could say my condensed logarithm would be log base a of 9x cubed plus 9x all over 5. And so now I've taken that 4-term logarithmic expression and written it as a single logarithmic expression.